Welcome back to iCar's Repairers Realm. Today we have a couple of representatives from 3M here with us. I am Bud Center, the Director of Technical Products and Curriculum here at iCar. And to my far right we have
Jeffrey Poole, Subject Matter Expert Team Leader here at iCar.
I'm Jason Scharton from 3M.
Ryan Marrinan from 3M, Application Engineer.
Well, Ryan and Jason, thank you for joining us today.
Thanks, Bud. Appreciate it.
We're going to talk a little bit about corrosion protection.
It's one of my favorite topics.
Favorite time. Everybody likes rust, I guess. But it's something that I don't think the industry really understands. As much as we've been dealing with corrosion protection forever, you still have, you go out into the shops and you see that they're using the wrong products the wrong way. They're not using the products that they should use at all. It's pretty interesting. What do you guys see out there with shops when you're going out there?
I think a lot of times, when we look at corrosion protection, they're thinking of a product, right, or a application, and really what they need to understand is that it's truly a process from the time you start repairing the vehicle until the time you present the vehicle to the customer of what we're using. And a lot of times, products that they should be using aren't being used or being used to the full extent that they should be. Is really what I see when I go see customers.
I would agree with you because you talk to a lot of the shops and they think that our corrosion protection is cavity wax. They don't think about all the other things that they have to use in order to have the right corrosion protection. So
yeah, absolutely.
All right.
Now, one of the things that we see is that there's a lot of focus on more advanced repair techniques and all the different types of substrates that we're dealing with. Certainly ADAS and EV are topics that are up and coming, but we can't forget about the fundamentals. And if we haven't done the fundamentals there with corrosion protection, anything else we're doing on top of it is really for naught. So something we believe very strongly in.
So I guess
something that affects the longevity of that vehicle and the structural integrity of that vehicle over its lifespan, whatever that may be. And that's, I think, something we have to think about as technicians as we're repairing the vehicles, that, where's that vehicle going to be in 4, 5, 6 years? And even if you're in a milder climate, you never know where that vehicle is going to go and what it's going to be exposed to. And then potentially what's going to happen. I'm responsible for the work I do to that vehicle and any effects I have on that vehicle. When I'm doing the work and in the future of that vehicle. So it's, in my mind, it's paramount that...
You bring up a great point, because one of the things that I've also heard quite a bit is, well, I'm in Arizona, right, and we don't get corrosion, and I don't need to worry about those processes like you do up in the upper Midwest. And you look at the way people are purchasing cars now, right? You've got car vending machines. They ship them right to your house. They're coming from all over the country. The vehicle that I drive actually was shipped from a southern state and now exists in a northern state. And it's, we need to be thinking about these things and how people are not only traveling but making purchases and having things shipped around the vehicle or around the country. Because, as you said, it's about maintaining the structural integrity of that vehicle after the repair for the life of the vehicle, not for 5 years, 10 years. Or until it leaves the shop and the taillights disappear on the corner. It's really for the life of the vehicle.
Right. Yeah, I think we've all seen those vehicles going down the road that you look at it and see, well, there was a weld on that panel and they didn't do the right thing, and now it's rotted through. And so it's pretty simple for us to see. But all right, well, I guess let's take it back to the basics, and we'll have Jeff and Ryan go give us some demos on how what we should be doing to do it right.
Absolutely.
Very good. Let's get to it. Okay, Ryan, walk me through the process.
Absolutely. So, Jeff, this is really where, again, as we talked about, right, cavity wax and when they think these inner panel corrosion protection materials are the one and only thing to stave off against corrosion, and it's really not. But I want to start here first, and we're going to come back to this, but just to show that there's no magic here, go ahead and write whatever you want on that panel.
That's my signature.
That's your signature? Well, you should be a doctor. All right, so we've got a dry piece, and you can confirm that that's dry piece of glass, right? There's nothing there, and this is truly an iCar coupon, which most every technician's familiar with it, or you should be soon if you haven't yet. All right, we're just going to set that in to some cavity wax here, and we're going to come back to
that's some of the cavity wax you sprayed in there.
Yep,
earlier.
So this is actually our amber cavity wax. We have two different cavity waxes. We've got an amber and we've got an opaque, and they're both the exact same product. There's just a color pigment added to one, and we'll talk a little bit about that when we come back to this frame rail, but we're going to let that kind of simmer for a minute here, as it should in the repair process. And I really want to go back and talk about where does the corrosion protection process start? Right? Because as you know, from a factory level, they're starting with corrosion protection from the time the adhesives hit the panel, right? And
even at the manufacturer of the steel, where they're doing the galvanneal or
yep, they're putting the galvanneal coating on there, and then they're going to come and we're going to do the adhesives, right? So in the aftermarket world, we need to make sure that we're choosing the right adhesive as per the recommendation of the OEM, and that's always the most important thing, right? Is always following what they're recommending and making sure that once you have the right adhesive, we're following the right application steps, and that includes panel preparation. Right? And this is where we see kind of the first mistakes coming in, because either they remove too much E-coat, and then don't get enough adhesive.
They're in there with a grinder with a big disc and potentially too coarse a grit, thinning the panel, and going beyond the parameters where they need to be in that repair joint.
If they got 36 grit and they're trying to grind a panel down, like, it's time to make some major changes in your shop, because that's not way too aggressive and abrasive. So in most cases, we recommend an 80 grit abrasive with our adhesives, but really many OEMs are really emphasizing a particular grit profile. Like Porsche's in a perfect example. They have a specific stone that they want their panel prepped with before the adhesive is applied. So that's really where we have to, emphasize the main focus right away is knowing that we want to remove the E-coat when required, because as you know, there are some OEMs that actually don't want the E-coat removed before you put an adhesive on. Generally, they're in like door skin applications, because that's part of their corrosion prevention, properties and the way the vehicle's designed. But then once we have the adhesive on, making sure that we're moving into that next step. And at the factory level, that's where they're going to E-coat the vehicle, right? And that's where their second step of corrosion
They have the
prevention.
ability to dip that vehicle.
They have the ability to dip the vehicle, and we don't. Right. So we have to take what is a one-step process for them, and we have to span it out a couple, across a few different
I think there's a key,
processes.
though, to that E-coat process, too. That's an electrodisposition where that vehicle body is charged, and that vat has an opposite, and it attracts. So there's an electrochemical reaction going on there that we absolutely can't reproduce.
Absolutely,
in the
and I've been challenged with this. Like, sure, if you're doing a restoration, there's companies out there that can do it, but we're not in the restoration business. We're in the collision repair business. So we're working on a quarter panel or a floor panel or a frame rail, and how are we going to replicate what you just described perfectly is the factory process, because that's really what it's about. We're replicating what the factory did. We cannot duplicate.
So thinking about all the different products that are available across the board out there from a variety of companies, in a spray can, that typically me as a technician, I want to grab the nearest thing to me and get something on there. Walk me through a bit of the thought process behind what we're seeing here. Help me understand.
So what we're seeing here is a perfect example of when we think we're going to be following what the OEM's recommending, as far as like, okay, we don't want to be using products to bare metal, right? And even though bare metal products exist in the marketplace, and they're not bad products, right? They perform exactly as designed. What we see is sometimes some missed steps. And really, when the OEMs are saying, like, we want to make sure we're putting it over a properly prepared and primed surface, right? Toyota Crib 186 is a perfect example of that. What they're referring to is a 2K epoxy primer, because if you go 2 paragraphs sooner in that bulletin, that's where they specifically call out the epoxy primer. As you mentioned, an aerosol is very fast, right? So they grab it, it's off the shelf. There's several, I would say, loose claims that are made with certain products, and they'll use it thinking that they're replicating that process as the OEM recommended. But as you can see here, we've got a perfect example of a 1K on top versus a 2K on the bottom. They're on the same exact side of the panel. The panel was prepped exactly the same, right? We put a seam sealer bead down the middle to kind of separate them, and it just shows the strength. This is the industry minimum test that we put it through. It just shows the strength of a 2K epoxy primer and how it is that we're going to replicate that E-coat. Right? There's really only one way to do it, and the OEMs I mentioned Toyota, Honda, GM, Volkswagen. A lot of them have position statements specifically calling out the use of a 2K epoxy primer for this reason, because they know in the aftermarket world this is a very high concern for them. Right? One of the areas that we see this concern is when using bare metal products is in wheel arches, right? So you get the wheel arch of a car, and you might have pinch welds through here. You might have a hemmed flange. We were talking about adhesives. One of the things with the adhesives is making sure we're cleaning out that oozed out material while it's still wet. Right? And actually making sure we're not re-exposing it by waiting for it to cure and then grinding it off. Because then you're exposing that edge, and where you might not be able to get a paint gun into the area. And as much as I like to make fun of painters, Jeff, as I think most all body men do, sometimes it's not from lack of effort or lack of trying. It's just that they just can't get the equipment.
There's a friendly adversarial
they
relationship
can't get the equipment in there, right? And a lot of times what ends up happening then is you get something, like this scenario here.
It's challenging, so down low on a rocker panel.
It's down low on a rocker panel, or you have a seam sealer bead and maybe it was put on bare metal.
You can only get that spray gun down far.
You get the spray gun down here, so if you look at it from this side, right, it looks like we've got good coverage, right, on that panel.
Looking at it this way, it looks absolutely beautiful. I want to say the side I can see looking down and under, if this were low on a rocker panel or something like this, but then, wow, we turn it this way and it tells a different story.
We turn it this way, and what's amazing about this example here is this only spent 4 hours in our tank.
Okay.
Right, so when we do tests like this, 500 hours is the minimum. This panel went through it just for 4 hours. So, and as you can imagine, with the world being the way that it is, everybody's very busy. When do customers bring their cars back, particularly with corrosion? Do they do it right away?
Nope.
No.
Because it's not showing the rust streak.
It's not showing the rust streak. It's not showing something. Right. The panel's not missing. I mean, usually they bring it back when they open the trunk to put the groceries in and they can see all the way through to the pavement. And they say, hey, there's a problem here, right? Now we've got a bigger problem. So really understanding that this process here will prevent us headaches long term. We still need this other stuff, and we're going to get to that. But this is really where we're talking about. Corrosion prevention is a process.
Right.
It's not an application, and it's not a specific product. It's a process, and that's what our industry really needs to understand is from the time we start working on the car, including disassembly, how are we protecting these metal surfaces? Because if they're going to get moved outside, right, if it's a panel that we're not replacing, we should make sure we're putting something on it so it doesn't corrode, because when we bring it back in, we don't want to strip any more of the substrate away than we need to.
We've seen enough examples of that where somebody had filler on a repaired dent area, and then the car got forgotten outside over the weekend, and then it comes in on Monday morning with a little bit of a rust stigma to it.
Right, and they think they can just buzz it down and still prime it.
Okay, probably not the right thing to be doing at that point.
Well, and since you mentioned filler, one of my other kind of pet peeves is when I see shops, they'll wrap the repair in plastic and park it outside, thinking that they're blocking that moisture or anything from getting to it, but what they've created is a greenhouse effect underneath.
Okay.
Right, and that steel or that aluminum, is we've talked about this. Aluminum is a very sensitive substrate, and they're finding that a lot of these mixed alloy steels are as sensitive as aluminum, and they're starting to oxidize almost immediately when they're exposed. And if we're subjecting them to these environments, it doesn't matter what we're doing, we're missing a step in the process. Where if it's going to go outside, realistically, it should have a surface primer, epoxy primer. Whatever the paint manufacturer is going to recommend that they're using at the shop be applied before it gets parked outside, right? So a lot of things that we can do to prevent that right away from the beginning, because once we kind of transition from that portion of the repair process, we get into our frame rail, right? And this is where, we've made our welds and we've got our frame rail assembled here. We've done everything that we can to protect this frame rail. We're now going to send it to paint. But it's not going to stop there. Paint will be the next step in preventing against corrosion, but really we're going to continue on after the paint process because we still have to protect in between these panels, right? If we didn't have adhesive in here, we've maybe got weld-through primer if it's recommended, and we need to make sure that any metal, including the weld itself, is going to be protected, whether it's a squeeze-type resistant spot weld or a MIG weld.
Whenever I think about repair planning and thinking through the whole process of what this vehicle is going to endure or go through as the vehicle's getting repaired. For me, there was a pivotal point in my career where I started looking at this of not just, I want to say, ripping the old panel off of there, but now how can I more methodically remove that panel, helping myself in the future steps that I need to do for reinstallation of it and minimize the intrusiveness and the damage to the coatings along the way.
Exactly, and one of the things that we like to talk about and we reference heavily is that, any damaged OEM coatings should be removed and, replaced following their recommendations and a paint company's recommendations, or adhesive makers. But in the event that it's not damaged, we want to remove actually as little of the OEM coatings as possible because that is what's best for that panel.
Absolutely.
Right? We can't replicate what they did from the factory. These coatings are baked at much, much higher temperatures. There's different chemistries involved in this stuff. And so unless it's damaged, we want to make sure it stays there.
So I'm curious, who did the welds?
That would be me.
Not too bad.
Yeah, you think you might pass me? I'm actually due for an iCar renewal.
We'll see you soon.
All right. So now that we've talked about what the frame rail should look like, one of the things, and we were talking about seam sealer, whether it's a one part or a two part, that I see gets missed a lot is making sure that we seam seal actually along this top flange here, right?
So that brings a question to my mind, and I get the top flange, and usually there's a weather strip that goes over this. But we know weather strips and rain and the migration of it and the capillary of that can draw it in. Would I also want to seam seal the bottom?
Absolutely.
Flange?
Yeah.
Okay.
So anytime you have, so think about it like this. When this was built originally, right, it went through that eco process that you so perfectly described at the very beginning. That sealed and protected all of these areas, which is why from the factory there was no seam sealer. Right. But then you look at like FCA's pre-refinish guidelines, now Stellantis, was it the third or fourth paragraph? They actually say any replaced panel, whether seam sealer was apparent or not, needs to be seam sealed. That includes frame rail sectioning points, top and bottom.
And we're not talking about big gobs of seam seal.
No.
You're looking at a pretty concise application to seal up the top of
Exactly. You're just running a thin bead on here because, again, there's multiple functions of seam sealer that I think that also is being missed in the industry. And a lot of times what we hear is, well, that seam sealer is included, right? And actually seam sealer is included, but you also need to replicate the original look and appearance, which is not included, right? And that's a different conversation. But for this application here, we're looking for the function of sealing the seam. And you're right, we're just going to run a thin bead, whether it's a 1K or a 2K, and we're just going to tool it off, clean off any excess, and then we're going to allow it to cure, and we're going to ship it off to paint. And then we're going to let the painter handle the rest of it, right? And that's going to give us a perfectly sealed, corrosion-proof,
within the best of our abilities.
Within the best of our abilities,
right.
while also following the OEM recommendations, as we talked about. And then once it comes back from the painter, hopefully they followed whatever the OEMs recommended. But then also, and I love to emphasize this because tech data sheets, they're there for a reason.
And I love the SOPs you all put together.
And the SOPs are there for a reason. Tech data sheets are there for a reason. And I bring this up because what I think is a miss for body men particularly, if they're in charge of applying the primers to the vehicles, there's actually a recommended nozzle setting, or nozzle size rather. Like, so if it needs to be a 1.6, right, or a 1.4, or a 1.8. It used to be the old theory of like, I'm spraying primer, put a 2.0 nozzle on there and
load it up,
dial it up, right? But the droplet size, the amount of material being applied, because they're testing their products to the same standard that we test our products. And so if you're not following their recommendations, you might be doing a process on the outside of this that is actually going to hurt the repair long term, right? So I just want to emphasize, like, from the front to the back, we need to make sure we're reading all the tech data sheets, following the OEM repair procedures and so forth, and documenting it along the way, because the paint process could destroy all this other work that we're doing if they're not following the process either. And what we're trying to prevent is this right here, right? We've got two examples here of frame rails. We've built these rails. There's actually two halves. I've only brought one half, but we've got one rail that we put cavity wax in, one that we didn't. And these were MIG and spot welded together. We put them through that environmental chamber. And when we took them out after 500 hours, this was the result in comparison. And as you can see, we've got some welds in here and so forth. And this is really what would 7 to 10 years of driving conditions would look like if we did not put the right protection.
So realizing that if I'm doing a sectioning joint following OEM procedures and they call for an open butt joint and it's going to end up being kind of a closed hat section or rail section like this, I may have very limited or no access to clean up this backside.
Yep.
And that's some of the thoughts that go through my mind of as I'm prepping this, what are my best practices in prepping that joint on the backside so I don't end up with a lot of the flaking burnt stuff that I don't really have a way to clean up. And I'm just thinking to myself, am I just going to load cavity wax on top of that? That's probably not a good idea.
It's not the best idea, but it's not the worst idea either. But from a peer application standpoint, before we make our weld, right? Especially while we have the new panel off on a stand, we want to strip that e-coat back. And this sounds, we talked about
that new panel is pretty easy.
Don't remove any more than you absolutely have to.
Okay.
And there's a reason why we're saying remove more than what they're actually saying in the repair procedures, so that we don't have any of that burnt soot.
Because we realize there's going to be enough heat.
Yep.
That's migrating over that it's going to.
And if our technicians have the welders set up properly and they know how to weld, and I'm sure they've all come seeing you and passed the test, they're going to have really good heat control. So we recommend 1/4 to 1/2 inch removal on both sides. Now, you mentioned a very good thing. Is on the vehicle side, some of these locations, it's very difficult to get in there.
So that prompts a thought in my mind of, if I'm replacing something, I have a scrap piece of metal that came off of there. It may not be very pretty, but that's a point in time where I have the opportunity to do some test welds on the material of right thickness. It may not be the prettiest in the world, being crunched up or whatever, but then starting to judge, okay, how far back do I need to push those coatings?
Exactly, and that's where you can take just a small portion, and if you take like a 1/32 cutoff wheel and just make a slit and then go back and weld it,
that makes it really efficient
right?
for me to do
Then
that.
you can flip it over and you can see what's my heat control and how far back would I have to go, because maybe the welder's set up exactly the way it should be, and the E-coat's burning back, slightly beyond a 1/2 inch. Well, then maybe we want to make sure we strip back a little bit more, and that's so not only are we setting up and making test welds with our welder, we're also looking for these other areas as part of that process. And this is where I think when technicians see and hear this, they get overwhelmed with, well, you're adding more steps. It's going to take me longer to do the repair. But really what we're talking about here, Jeff, is we're just talking about something that becomes almost natural when you do it long enough.
Right.
Right.
And as a technician, I think about that, and I think about the longevity of that repair and the future of that vehicle, and we don't know what the customer's going to do with that vehicle out there.
Exactly.
It might have to prove its worth 100%, and as-built structural is what kind of we're looking for. We follow the OEM on what's the repair process, what's the sectioning process if there is one, and ultimately for this plays into the longevity.
This is definitely in the longevity, because the structural integrity of that weld is very, very important, right? As you know, because we're going to be doing our grinding and our finishing on this side, and having that penetration, it's more than just making sure we have good penetration. That's actually providing the strength to that weld area, and working in that whole crash energy management, and really understanding that like this is going to have reduced crash energy management just because the materials are corroding.
Once you start eroding away, then the integrity goes.
Right, exactly. So, all right, Jeff, so safety first. I'm the least attentive to safety, so that's why I leave them laying out here in front of us. So we want to talk about like more of the why and what happens when we're putting in these cavities, because we're blindly putting it in there with our fingers
I can't
crossed.
see inside of there.
Right? That, oh man, I got enough in there. And one of the things that I hear a lot is, I like using a certain product or brand of inner panel corrosion protection material because I know I've got enough in when it's running out all over the floor.
And I've had the drip pans underneath the rocker panels before.
The piggy mats, the drip pans, right? We've all done it. We've all been there.
Because that mindset is, let's just flood it.
Flood it, because then for sure I've got enough in there. But then I talk to shop owners and shop managers, and they're like, who's going to pay for all of this?
The waste.
Right? All of the waste on the floor, and then they're going to drive through it, and then they're going to walk through it, and we're tracking. Heaven forbid you'd roll in it. I've done that.
Next thing you know, it's splattering up on the floor.
It creates a mess. So one of the things that we and I have the luxury of doing is working with the OEMs and understanding more in depth of what are the requirements, because there are actually a lot of requirements for the application process and what the material needs to do. And one of them is, like, Subaru does a really good job at highlighting this, and particularly on their door panels and rocker panels. There's a certain mill build that has to be maintained on that surface for the life of the vehicle, right?
And I'm probably not getting in there with my mill thickness gauge and trying to measure that.
Exactly. You're not going to get in there and you're not going to measure it because you don't have access to it, and the material will be wet, so you're wet milling at best.
I'm going to have to understand about how much am I putting on.
Yeah, and so when we talk about using our products, we talk about 3 coats, right? And we're using 3 coats to achieve 30 mils of build. Now, wet build is going to be a little thicker than dry build, and there's a little bit of difference there. So when you put in 3 coats, everybody goes, wow, that's really heavy, but there's certain solvents that will evaporate, and the material itself will never cure. It stays in a fluid form, paste-like form for the life of the vehicle, because it's important that it never dries. We don't want it to
learn that as technicians when I put our arm back inside the door, putting the window regulator together.
You get full of it, right? Yeah. So we need it to stay where we put it, right? It's going to be there for the life of the vehicle, and it's very important part of that process. So what I want to have you do to highlight this is, I'll get this set up for you, and you're going to use one of our wands from our wand kit here, and this is our 22-inch wand. And just so I don't spray any, I want to make sure that the nozzle's fully attached. And I'm going to have you pick either one of these bottles that you want, all right? You've got green tape on there. I'll even help hold the bottle here. And you're going to apply 3 coats. So when I say 3 coats, I'm saying depress the nozzle, come up to the top till that next green tape comes, all right? Let off, go down to the bottom, and apply another coat, and then a 3rd coat.
So when I think about this setup, if I was doing a rail and I knew I had a joint area, I'd mark my wand accordingly.
Yep.
to adequately coat well beyond
Yep.
each of
And
those,
that's really, and
each of
that's a
those
great
areas.
point, because this is another thing that shops talk about is, when they say, well, post-repair inspectors come out and, they're not seeing the cavity wax, in their cameras if they're taking pictures. As you know, a lot of these section points, like this being a GM, this is very far forward on the rail. There's going to be a wheel liner that comes down here.
Yeah.
Right? So it's not a bad thing to put cavity wax in the entire frame rail. It's actually a really good thing.
Yep.
And we want to make sure we're getting protection, but more importantly, because where they'll have an access point to put that camera in to take the picture, we want to make sure that they're being able to see.
Now, in some cases, I may have to go in through an access hole or something in the side of the rail, depending on where we're working on a rocker or something like that.
And we actually have a longer wand than this, so we've got a 33-inch wand as well. So this is just our 22 to kind of be comparable
I've
here.
seen technicians take a small piece of like coat hanger or something and tape it so they can, I want to say, bend it
into a certain
and then get it to
articulation.
where once they get it back in there, they can control it a little bit better. Sometimes it's a little tough. But
Sometimes they get to be engineers.
So you're telling me to.
So we're going to put 3 coats. Now, before you start, I do want to say, so our recommendation is that we apply 2 coats.
Okay.
We allow it to flash off for 5 minutes before we put the 3rd coat in, right?
Yep.
Now, you and I both know that the industry is built on speed and technology, and faster the better, and we want them to follow the recommendations. However, we know some people don't. So I'm going to allow you to put 3 coats, wet on wet on wet.
So we're not going to do any video magic here. I'm just going to take and. Now, is my speed too slow?
You're fine. I actually like you because you're going to use more material, so I'll sell you more. So speaking of which, we get a question too a lot about how much material do I need to apply inside the vehicle, and we talk about 3 coats, but then they say, well, how much should my shop be using, on a weekly basis? And what we say is we've done studies and tests on this, and we've looked at different manufacturers and different applications, and what we've found is that on average, for about 80 hours a week, which should be about 200% efficient in our industry, there should be 1 can per technician per week being used. Right now, there's obviously some exceptions to that if you're just doing, small express repair bumpers, stuff like that, where there's no metal or aluminum damage. Then we don't have to worry about it. But for most every other shop out there, we're fixing dents, right? Whether we're doing glue pull dent repair, which also disturbs the E-coat when the dent is formed, right? So there should be cavity wax being used for that. Any stud pulling or welding that's being done, any hammering on the panel, any rod pushing, paintless dent repair, like all these things, I always tell people, like, you don't need to actually use our product if you're not doing these things, but that's how we make money, right? So if you're going to be...
And so if we're doing anything that's disturbing those coatings, or if the damage to the vehicle would disturb those coatings in any way, these are things we need to think about.
Exactly, because as we were talking about at the beginning, when you talked about that electrodeposition coating that the vehicle's going through, this is now how we're replicating that on the inside of the panel. Right? And we're making sure that we're doing it as long as you like your painter. We're doing it after the paint process. If you don't like your painter, go ahead and do it before the paint process. But
not going to be happy.
No, they're not going to be happy. So our recommendation, as we're joking here in all funniness, but really it's after the vehicle comes out of the paint shop, and I would say before or during reassembly, because as we're going to come back to another thing in a second here, there's more to this that's happening than it's just sticking to the sidewall. Okay, so
why the other bottle?
So I want to have you try another product here, and we talked already about, I use this because I know I got enough running out on the floor, and you and I have both been down this road before and used a product similar to this.
And this one calls for 1 application.
This, on the can and in the technical data sheet, it says 1 heavy coat. So I'm going to let you determine what 1 heavy coat is.
All right.
I'll hold it this
All
way.
right,
so
1
you can see
heavy
there's
coat.
So 1 heavy coat.
Yeah, it's 1 heavy coat to me.
All right. So now let's go back to that Subaru repair procedure. Hey, you flip it around that way. There you go. So let's go back to that Subaru repair procedure.
Okay.
Right? You got to maintain a certain mill build on the surface of the vehicle. And we go back to like why 3 coats 30 mils. In all of our research, we wanted to make it easy for our customers. Right? Rather than going through every repair in every vehicle, right? We just need it simple because simple is better. So what we found was on average that ranged from 2 mils to 27 mils of build required by a variety of OEMs. So we thought, let's just make it easy. We did a bunch of measurements. We said, hey, with 3 coats, whether you're using the actuator just on a backside of a fender, or you're using the straw, the wand kit, we're going to achieve 30 mils of build. That's going to cover everybody. It's a simple application at that point, right? And we know with 30 mils, we're going to have beyond 1,500 hours of protection. What does 1,500 hours equal to? Well, loosely translated, you're looking at 25 to 30 years of protection or more, right, on that vehicle, as long as we're following all of these procedures and getting through that step. So now, right, you saw it right away. You look down here about, so now, what is happening in here? Do we have adequate protection?
A lot of it's run off, and it's probably
a lot of it's run off. Now, to be fair, right, give it about 15 or 20 minutes, and I'm going to show you why that's important here in a second. But give it about 15 or 20 minutes, and this is actually going to start to subside, and it will flow a little bit. And then one of the things that our customers will say is, well, your product is just too thick. I can't see it running out the weep hole, so I don't know that I have enough in there. Goes back to that if you follow the SOPs.
Oh, if it's running out the bottom, I know that it's at least...
It's at least in there.
Yeah.
So it will start to subside, and it will start to drip, and between 20 minutes, or between 15 minutes and 30 minutes, there will be some material in this cup. Usually, the full application, we only lose about 5 to maybe 10% drip out in a scenario like this, where some others are much, much higher, right? Yep. So I want to take these down, and we're going to transition here to another application. Now, we've all seen the pop, hell, we just did a pop bottle demonstration, so let's talk about what happens in a real frame rail. Okay, so now we've got gusset plates in here. We've got a scenario that's very similar to what our technicians are dealing with.
Right.
So all of these walls are dry. Again, I'd be surprised how often I get accused of magic. I don't have time to learn magic. I'm not going to perform it.
If I knew magic, I'd probably know the lottery numbers.
Yeah. Speaking of which, I bought a ticket. I wonder if I won.
Good luck.
I haven't looked, which is why I'm here today. So
I didn't
assuming
win the
I still have
so.
to. All right. So I'm going to have you apply, and I'll move this closer to the edge here so that your can doesn't bump into the counter. All right, I'm going to have you apply 3 coats into this, and believe me, the first one's going to be the easiest. The next 2, you're going to be blind.
Oh, great.
Yeah. So go ahead and move forward a little bit more.
All right.
There you go. All right, so go ahead and apply 1 coat first. And I love the fact that you're just pushing the nozzle all the way. You'd be surprised how many people want to try to feather it, and just push the nozzle, apply the material.
Hey, I'm on production.
There you go. All right.
The risk.
Oh, you're way better at this. All right. Here comes 2. And with our wand, we actually have, so you'll actually see like a heavier streak through here. We actually have, we say it's a 360 wand, but really if you look at the nozzle on there, we've actually got beyond 360 degree coverage.
There we go.
Yeah, 1 more to go.
Yeah, we'll figure it out eventually. There we
go. So with that beyond 360 coverage, plus you'll notice too that when we apply the material, there's actually a slight foamingness that's happening when you use the wand kit to install it, and that's actually by design. So we've actually got some trademark secret products within our material that allow this action to happen, because when we look at what happens inside, we've got 360 coverage, but now look at how much we've got on these sidewalls. Right? These were perpendicular to our spray pattern, but we got material on there, and we even got material on the end without even a nozzle in the very end.
So what causes the foaminess?
So it's actually by design, and so this is so it reaches out and touches all the little brackets, all the little gusset plates within the repair. And as I mentioned with the pop bottle demonstration, this will actually subside.
Okay.
Right? So it's not going to stay foamy like this.
Kind of like foam in the dishwater.
Right? And this is actually by design. So when I say it's by design, I'm going to set this over here for a second. I'm going to actually take off my messy gloves, and I'm going to have you do the rest for me. So when I say it's by design, now I actually want you to pick this steel plate up, and we haven't had a chance to look at this, but...
Oh, wow. So this material has, through capillary or wicking action, I think that's what you termed it earlier, been working its way up through here. It hasn't completely engulfed the whole thing in this time frame yet.
And this is a perfect example of, because people will call that out, and they'll say, well, look, it didn't get that spot right there, but what did it do?
It surrounded it.
Surrounded it. So that tells me that there is so much pressure applied right there that it can't wick inside there. Now, if we were to break these loose and then reclamp them, this would all be covered within minutes, right? And same thing up here. So the beauty of this, and I travel with this and I use this everywhere. I could have dropped it. I might have dropped it when I was loading it in the vehicle. So it changes every time I do this demo.
Yeah.
The big thing is here, now we've had this in here for less than 30 minutes,
Right.
right? So in less than 30 minutes, we've achieved 5 inches, right, of vertical climb, capillary action in the material. This is why we say when we put it in there, it needs to stay. Remember when I said you need 15 minutes of the material to not sag?
Yep.
Because this is what's happening. So now when we put it in this frame rail, right, how are we going to get vertical capillary action of the material?
Coming up into this.
Coming up into this. So we've got these edge seam sealed.
And once I've got the proper application in there, it's not like I'm cutting the car back apart. Right
Exactly.
away.
You're not going to cut it open. You'll never.
That's just going with the car.
So this is where you have to trust the products that you're using and make sure that the products are not only recommended by the OEMs, and if they're recommended by the OEMs, chances are they went through extensive testing, right? We've got teams back in St. Paul that's their job. We run these tests constantly, day after day after day, to make sure that we're meeting these certain standards on a regular basis.
This wand, it's reusable. I just clean it with the gun cleaner?
Absolutely.
Okay.
So you can do one of two things. You can use the high-powered gun cleaner to actually clean out this wand. You know, you could use wax and grease remover, or you can simply just invert the can into a garbage can or into a paper towel and then just wipe off the excess on the outside, and it stores in the original packaging.
Okay.
Right. So that's another thing too that's extremely important, because technicians will say, well, your wand kit is more expensive than another brand. So I buy the other brand. It's like, but they're not disposable.
Yeah.
If you take care of them, you could get 6 to 12 months of use out of them. So I say it's a pretty good $29 investment because there's 3 in the kit, and it works with both of our products.
Mm-hmm.
And if you take care of it, you know, it'll last you for a while.
So over here we've got a spray gun, and I'm no expert on spray guns, but what's the purpose of this, and how does this play into our corrosion protection process?
So one of the beauties of the spray gun that we just recently released is, you know, we talked about application of epoxy primers, right? We have the ability within one gun body to change out the heads so that we can quickly pivot to, say, like a urethane requires a 1.8 application. Yeah. Maybe if you're using a urethane, you have to use an acid etch. Maybe that requires a 1.1 nozzle or a 0.9 nozzle. And then you go to spray your epoxy primer, and that might require a 1.6 or a 1.4, depending on which brand you're using. It can do that very, very quickly. The other benefit is you notice that it's set up right now with what we call the HO cup. Part of the corrosion protection process is knowing that there's gravel coatings applied to vehicles, and sometimes they might be applied in areas that didn't originally have it from the factory. Right. A lot of times we see that with undercoatings, like in the wheel wells or on floor pans. You replace a trunk floor pan, they might require additional material that wasn't there originally. We're able to achieve not only great application, transfer efficiency, but we're able to match and replicate these looks and appearances, these textures at a very low air pressure. I'd be very surprised to ever find a technician that needs to spray an undercoating, a gravel guard coating. We've even put bed liner through here. Now, bed liner is the exception, but with our coatings, if you're ever over 20 psi on the regulator, we've got some issues. Right, so it's very low, application pressure, which means there's not going to be a lot of overspray in your booth or in your prep deck area. Right. But again, the coatings is one of the key important areas, and we just kind of highlight this as that application. And the beauty of this particular gun here is you'll notice there's a valve on this side. Mm-hmm. When this valve is closed, you can put a regular PPS cup and liner on here, and it becomes a standard spray gun. That's how we're able to quickly transfer into putting on primers, right? So it becomes a very versatile tool with one solid body when taken care of. You can do quick changeovers, and it's actually a very critical component to the full corrosion protection process.
Very good. I think at this point in time, it's time for us to join him back over at the table.
Absolutely.
Thank you very much.
Thank you.
All right. Well, Jeff, Ryan, great information. Great job over there. Thanks for the demos and helping everybody understand what they should be doing with regard to corrosion protection.
Yeah, I think about a few of the vehicles I worked on years ago, and I think, I wish I could revisit them.
Yeah.
Well, and you're not the only one. We run into this a lot, and I'm in the same boat you are, right? We don't know what we don't know, and hopefully, now that you've gained this new knowledge or information, this is really like a new starting point to from here forward, let's make sure we're making the proper repairs, because that's really what the focus should be. Now we've learned new information. Now we need to make sure we're implementing it, and we're not going to ignore it.
Perfect. All right. Well, if there's anybody out there that is watching this video on demand and you have any questions, you can submit those questions to repairersrealm@i-car.com, and we will get those questions answered for you. Ryan, Jason, thanks for joining us.
Thanks.
Absolutely.
Thanks,
Thank you guys.
And thank you all for joining us.